Step outside on a clear night and look up. You'll see thousands of stars scattered across the sky, tiny points of light stretching in every direction, each one a massive sun burning with unimaginable energy somewhere far beyond our solar system. Now here's the part that should bother you. If the universe contains billions upon billions of galaxies, and each galaxy holds billions of stars, and those stars have been shining for millions or even billions of years, then why isn't the entire sky blazing with light? Why is most of space black? Why does the universe look like a dark ocean with only scattered sparks instead of a wall of endless brightness? It feels like it should be glowing everywhere, but it isn't. And the reason why reveals something profound about the nature of the universe itself. Welcome to Simple Things Why and How, where we take questions that seem almost too obvious to ask and uncover the deeper truths hiding inside them. Today, we're stepping into one of the most fascinating cosmic puzzles ever explored. If there are so many stars, why is space dark? To answer that, we have to rethink what darkness really means. At first glance, the logic seems straightforward. If you stand in a forest and look around, eventually your line of sight hits a tree. If you stand in a crowded city and look forward, your view ends at a building. So if the universe is filled with stars in every direction, then no matter where you look, shouldn't your line of sight eventually end on the surface of a star? If that were true, the entire sky would shine like the surface of the sun. Night wouldn't exist. Every patch of sky would glow. This idea even has a name in astronomy. And for centuries, it puzzled scientists who couldn't reconcile what they saw with what logic seemed to demand. Because clearly the sky is mostly dark. So something in our assumption must be wrong. For a long time, people assumed the universe had always existed. If that were true, and if stars had been shining forever, then light from every direction would have had unlimited time to reach us. In that scenario, the night sky really would be bright. But here's the crucial detail. The universe has not existed forever. It began about 13.8 billion years ago. That means light has only had 13.8 billion years to travel. And while that number sounds enormous, on a cosmic scale, it creates a limit. There are stars whose light simply hasn't had enough time to reach us yet. When you look into the darkness, you are not just looking into empty space. You are looking into regions whose light is still on its way. Darkness in this case doesn't mean absence. It means distance. It means time. Now here's where it becomes even more fascinating. The universe is not just sitting still, it's expanding. Galaxies are moving away from each other, stretching space itself as they go. Imagine dots drawn on a balloon. As the balloon inflates, the dots move farther apart. That's what's happening on a cosmic scale. And when space stretches, something strange happens to light. It stretches too. Light traveling across expanding space becomes longer in wavelength, shifting toward the red end of the spectrum. If it stretches enough, it moves beyond visible light entirely. It becomes infrared, microwave, or radio waves, forms of light our eyes cannot detect. So, some of the light that could have brightened our sky has been stretched into invisibility. It's still there. We just can't see it. When you look at the night sky and see darkness between stars, it feels empty. But it isn't. That darkness is filled with radiation, particles, distant galaxies too faint to detect with the naked eye, and something even more astonishing. Ancient light left over from the birth of the universe itself. Scientists have detected this faint glow, known as the cosmic microwave background, which is essentially the afterglow of the Big Bang. It fills all of space, but it doesn't shine in visible light. To our eyes, it's invisible. So the universe isn't truly dark, it's just dark to human vision. The reason space is dark comes down to three powerful truths working together. The universe had a beginning, which limits how far light has traveled. The universe is expanding, which stretches and dims distant light. And the universe is so vast that much of its light is either too far away, too faint, or shifted beyond what our eyes can perceive. What we call darkness is really a combination of distance, motion, and limitation. It's not that there aren't enough stars. It's that the universe has rules. And those rules shape what we see. There's something poetic about this. The darkness of space is not a failure of light. It's evidence of a living, expanding cosmos with a history. If the sky were completely bright, It would suggest a static, eternal universe. Instead, the darkness tells a story. It tells us that the universe had a beginning, that it is still changing, that we are looking across time when we look across space. When you stare at a star, you are seeing ancient light, sometimes hundreds or thousands of years old. And when you stare into darkness, you are seeing the limits of how far the universe has revealed itself to you. That darkness is not emptiness. It is unfinished information. So why is space dark if there are so many stars? Because the universe is not infinitely old. Because space itself is expanding. Because light has limits. And because our eyes can only see a narrow slice of reality. The next time you look up at the night sky, remember that the darkness between the stars is not a void. It is a reminder that we live inside a universe still unfolding, still stretching, still revealing itself piece by piece. If this changed the way you see the night sky, take a moment to like the video so more curious minds can discover the story written in the stars. Share it with someone who loves looking up and wondering what's out there. And subscribe to Simple Things Why and How, where the simplest questions often lead to the most extraordinary truths. I'll see you in the next one.